Well, greetings, people of the internet. Unky Joe here, Unky Joe's Playhouse. Today, right tool for the right job, I always say. The Windows is the right tool for this job. That's right. And we're going back to I think I got the webcam up and running because when I upgraded my machine here to Windows 11E LTSC IoT, which I highly recommend you do. I will have a whole other video on that. I didn't get the Canon set back up right, and frankly, I'd have to get up and close blinds and turn on lights and turn. I just didn't feel like it, but I wanted to get this video out. So now that we got that out of the way, what the hell is this? This is the Dell R730. Remember that little beastie that I bought a few years ago, a couple years ago? So this little beastie has got a couple of dual Xeon E5 2697 V4 processors and quite a bit of memory, like 256 gig. It also has a couple of 10 gig, I think two 10 gig and two 25 gig SFP connectors. Sakura will correct me if I'm wrong. And then the other thing it has is two of these Tesla P40s. Each one of these cards is 24 gig of VRAM and, a bunch of CUDA cores on there. And these are old CUDA cores. So this is where the right tool for the right job comes in. With these cards, I'm not so much wanting to split it up and give it out to virtual machines. I'm wanting to use these cards natively under Windows for tasks like LLM, using it for the LLM models, using it for maybe local decryption and encryption of video if I need it, that kind of thing. To where if I ran a native Windows program, it would have direct access, through a driver, to these video cards. Because I really don't have a need to give up these video cards to virtual machines. Now, the other thing this machine is great for is creating virtual machines, right? So I had a couple of choices. I could have run Proxmox in theory and set up, a pass-through of these video cards to then a Windows virtual machine that then would have them, in there and have a bunch of... It just became kind of, why don't you just use Windows on it? And if you need to create some virtual machines, like for a lab, then you'll have this running Hyper-V as well. And that's the key right there. This is running Hyper-V as well as serving the needs for a program like LM Studio. We'll get to that in a minute. Now, I initially had Proxmox on here, and it was running well. I was very happy with it. And I had even done a video on splitting up this video card, because there is a way to split up these video cards and parse them out to virtual machines using, some Docker containers, some Python scripts, and a whole lot of knowledge on how to do that. And even then, at best, it's kind of quirky how the licensing works. And it's more trouble to me than it was worth. So I got to thinking, we still want to use these video cards because, I went through hell and high water to be able to afford a couple of these video cards. Even the couple of years ago when I bought them, they were still several $100s per card. And I don't like throwing that technology away. And what I discovered was that under Windows, and it could be Windows Server 2019 or whatever Windows server you want to run, getting these Tesla P40 video cards to work in what they call WDDM mode is not that difficult. There's in fact, Linus Tech Tips has the article I use repeatedly to make that happen with a specific driver. You'll notice that the driver on these video cards is not the current one. It's like from 2023, but it works for what I'm using it for. And the icing on the cake is it works with something like LM Studio. Now, I can still install Olama for Windows on here if I wanted to, and it would work just fine. And then I could point my Open Web UI on another machine on a server to using this Olama running on here as a point to run the large language models. In fact, I'm going to do just that because I want to show you not only is Proxmox and Linux great to run your servers on, but if you have the need and you have some certain specific tasks like I do, why not just run Windows Server on it, right? Get the best of both worlds. Now, I'm going to be honest with you. I'm not a big fanboy of LM Studio. It works. It's okay. I just find Olama with Open Web UI as the interface, the front end, to be more my style. Okay, but your mileage might vary. But the beauty of LM Studio is it's gotten so much better over time. They've really added some features. They've listened to end users, and it is a free program. I mean, the thing is running great. And one thing they're really good at is keeping their run times backward compatible. You'll see that we've got, the Vulkan Llama, CCP, the CPU Llama, Harmony, even the CUDA Llama are all here and ready to be used. Now, if you come over here to hardware, you'll notice that it sees my two Tesla P40s, and they're using actually the Vulkan drivers. So, and I've got it set to split evenly, but I could, I guess I could turn one card off and just use one. See, it sees the full amount of RAM we have, it sees the CPUs we have, and it sees the available video RAM. So even these Tesla P4 cards are still supported by LM Studio. At least their drivers are. I don't know about Olama. Again, that's something that's on my list to do. Olama for Windows to load it on here, but I think it'll work just fine. Now, what I wanted to share with you is my chat history, and I've really kind of fallen in love with this new model, the GPT OSS-20B. It's a 20 billion parameter model, which means it'll fit and get split, as you can see here, over two of my video cards. If I go ahead and I'm going to fire it up and ask a question. Let me bring this down and then we'll come back. Just wake it up. Are you available? So as you can see, it's going to start loading the model, and it's splitting the load. So the model is about 12 so far, 6 gig on one, 7 on another. So yeah, it's about 12, 6 and 6, 12. Processing's going pretty well. And you'll see our response rate is 46.82 tokens per second. That's pretty darn good for that card. So we'll just show you how fast it was and some of the prompts I used. I have a bunch of standard questions I like to ask so I get consistent results from machine to machine, model to model, whatever. So I told it to create a Flappy Bird game called Flippy Block Extreme. Now, I have not tested this script to see if it even runs. I'm doing this more or less to see how it does with the code and to get an idea of the generation time. So that model, that code took 29.09 tokens per second, and it took 3 seconds for its first token. Okay. Some questions it won't answer, like the massive asteroid dilemma. Do we kill the crew and go on with the mission, or do we just choose not to answer? And it chose not to answer. And it did it. It took 5 seconds to not answer. So it took a little longer to think. And then give me a random sentence about a cat and, count the number of words, etc. Again, 25.79 tokens per second. And it did about the same all through this. So we're getting I would say anything less than about 10 or 15 tokens per second is just go find something else to do. You'll get an answer eventually, but you may not like to wait on it. So we're getting between 20, 25 and 40 tokens per second. I say that's pretty good work. 22 tokens, especially for a model this size. So it's a nice middle of the road size wise model. Now I can also I don't know if I have one a larger one. Yeah, I do have. I have the 70 billion instruct model. Now I'm going to go ahead and load that, and we'll just see how that does. You'll see it dumps the memory, and then once it's dumped it from both, then it'll start loading it back into VRAM. But it's also got to read from the hard drive or the SSD drive. Now these models I have stored on a RAID 10 array of spinning Rust disks. So sometimes it'll take a little while to get that data into the model. I probably should start a new chat, but I didn't do that for whatever reason. Now it's going to load the model before it starts. I mean, it's going to load the model into probably RAM before it starts loading into VRAM. I don't know exactly how it does that. To be honest with you, I'll just be honest. I do not know. But this is a 70 billion parameter model, the Llama 3.370B Instruct. And I don't expect to get phantasmagoric performance out of it, but you'll see it's starting to gobble up VRAM on both cards. So hopefully the model will load without taking a huge, enormous dump at the end. So it's loading the model into memory. That takes a little bit of time. Now I know a lot of you are not the least little bit interested in AI and the technology behind it, or these large language models, and I appreciate that. Appreciate you being honest with me, but I like these large language models. I find them very useful, and again, I like having something for the computer to do. Now, you notice that one card is using 100% of the GPU, and about, I'd say, 90% of the RAM, 85% of the RAM. There we go. So now it's letting the other one take some of the load as well. And we'll see what kind of answer we get here eventually. But it's just kind of cool to monitor what card is doing what. And we could go to the processes. Here we go. It really doesn't tell you what card you're choosing. But that's okay. It is processing the prompt now, so that's good. 25% processing.
346 minutes later.
This thing pulls about 370 watts when it's up and running. I've seen it go as high as 400, I believe. Each video card, I think, can pull 150 watts. I might be talking out my rear rectum again. Check it out though. I mean, we could easily look that up. It might be higher than that. It might be. I doubt these cards are 250 watt. Well, now I've just got to know, All right, so we're at 50%. So let's do this. Let's do this. La da dee dee dee. Okay, yeah, it can briefly exceed 250 watts. but is capped by the card's power delivery. It's interesting. So it gives an answer, but not really an answer. Yeah, reported total purported draw of up 287 watts. And I believe with it's still processing. I believe with Windows, we can see exactly how much power it's using. Yeah, there we go. So it has the capability of using 250 watts per card, but it's only using 100 watts on one and 13 on the other. And yeah, NVIDIA SMI will run on Windows as well. That's how you know you're in WDDM mode on these drivers. Cool. All right. Well, let's see if it has answered. There you go. 3.56 tokens per second. So I'm going to ask it explain the meaning of AI. See what it says. Spike gonna have to think long and hard on this. But it's answering quickly, so that's right, it's not a thinking model. That's all right. It doesn't mean it doesn't think, it just means it doesn't, take that time. So it's okay. So even though we have enough memory to load one of these larger models, I really don't think it's good for anything I might use one of these models for, which is day-to-day stuff. But it does give us the ability to load these larger models that I normally wouldn't be able to load at all. I mean, even with two 3060s, that still only gives me 24 gig of VRAM, whereas this gives me 48. But I can load those larger models on this. The trade-off is the kind of response tokens that I get. But perhaps that's okay. Perhaps it'll teach me to appreciate these larger models, larger quantization or whatever they call that, the larger physical models, and convince me that it's worth spending a little more money to get two video cards with maybe 24 gig of RAM on them or 32, and then have a total of 64 gig of VRAM if it's worth the investment. However, that answered that question pretty well for me. It gave a summary. It was pretty. Does it mention any? It didn't mention any pros or cons or anything like that. But 3.53 tokens per second on a 70 billion parameter model on video cards that are, well, these aren't even video cards. These are data center cards, through Teslas. They're not exactly made for AI, for modern large language models, but they still work for it. And you still get 4 tokens per second. That's not bad at all. That's not bad at all. And you can see it's hardly putting any load at all on any of these CPUs, and Windows is gobbling up a lot of memory, and that's good because we get a lot of memory for it to use. I'm not worried about that at all. Everybody's like, Windows is a pig. Yeah, it can be. When you give it a lot of RAM, it'll use the shit out of it, and it becomes faster. I like it. Anyway, so there you go. LM Studio running. Again, we'll do a Llama. See if I can get that to run. Not in this video, but in a future one. But there's one perfect use case for why sometimes I just want to run Windows even on a server, because I can do certain native Windows applications that would be a pain in the ass to do through pass-through and having to deal with that. And, Now, the other thing this server is well suited for is virtualization. So I'm also going to show you how I've got things set up for my virtualization. to run Windows virtual machines under Hyper-V on this server. And then I've got another server, which I'll be doing another video on. It's a Lenovo that I've also got Windows Server 2025 loaded on, and how we're going to use these servers together in some of our home labs that we're going to be setting up. In fact, I just kind of let the cat out of the bag. If you look up there, it'll tell you what lab this is. And I thought it was apropos to name it that. But let's see how I've got this configured, how I've configured Hyper-V. Now, I do have to tell you that there is no dark theme for Hyper-V Manager that I'm aware of. And I apologize for that, because that is the ugliest looking interface. You know what? I'm going to go check that. So, yeah, Grok knows everything. There's our answer right there. No. There's some workarounds, but no. So, sorry. So, yeah, that's one of the problems, is that it's very, very bright. Okay, and, you know, the controls are, I mean, I'm used to it. I've been using it for years, and I actually love Hyper-V. It's very stable, very easy to use, very forgiving. But, you know, also it's by Microsoft, and that means that at any particular moment in time, for no particular reason, they may change things that may break it moving forward. So just be aware of that. Now, some of the things I like to do ahead of time, come over here and right click on the Hyper-V Manager and go to Settings and set a location for your virtual machines and your virtual hard drives. Now, I've always set the virtual hard drives and the virtual machines in the same disks. But more and more people are telling me, or more and more professionals I've heard from tell me, you should separate the machine from the hard disks, just to, because things. So, all right, I'm going to do that. But I'm not going to do it here. And I'm not going to do it right now, because I have other VMs running and I don't want to break them. But in the future, I'm going to take that over to the spinner drive and put it over here on Spinning Rust. But for now, we'll leave it alone. Live migrations, well, we're not going to really get into that, because we don't have these set up. Specifically, I haven't set these units up on a domain, because I don't want to create the chicken and egg syndrome. So we're not going to use migrations. So the big one is the virtual hard drives and the virtual machine locations. So you can set them to be the same, or you can set them to be two different places. I'm going to tell you something else. I always create on my Spinning Rust, if I have it available on the server, a location for ISOs, and usually a location for something called exports, which are basically ways to back up a virtual machine. But it's tricky. Now you're saying, Joe, just point the server to the ISO folder on your network. And yeah, it doesn't work that way for whatever reason. And I believe it's a permissions issue. So for example, if I were to go create a new virtual machine, let's just do a Windows 10 Enterprise. We'll do a 10E IoT-01. That's what we'll call it, okay? Click on next. It's going to be a Gen 2. Yeah, we'll give it 4 gig of RAM, because why not? We can use dynamic memory. We'll give it a network connection. We'll give it a hard drive. We'll tell it to install the OS later, and then we'll click on Finish. So if I go right-click and go to Settings now, I can come here and add a DVD drive. So I'm going to add that. And I'm going to do the image file, and I'm going to browse. And, well, I've got no mapping. So let's go to Network. There it is, DS1621. DS1621, ISO, template, ISO, and then I should have a Windows 10 ISO in here. Let's see, Windows 10 Enterprise LTSC Internet of Things. Let's see. Now there should be one October 2025. That's server 2022. Yeah, this would have been about the time. Windows 10 Enterprise LTSC. So let me open that, apply that, and it'll tell you right here, failed to open attachment because the username or password is incorrect. So I've run into this before. I've had people ask me on these videos for Hyper-V, why don't you just, do a mapped drive letter? Well, here's the problem you run into. And this is very similar to what happens if you try to export a virtual machine to a network folder of which this machine is not a member of. If I'm not a member of that domain, I get the same error. So, but I don't want to join this to a domain because of the chicken and egg syndrome. So, what I do have is a couple of 2025 servers set up right here. So I have my DC1 and DC2 for the LabNet 69 network. So now one thing I did want to share with you on this server is how I have my drives set up. And look, if I'm going Windows, I'm going all the way. And that includes storage pools because I've used them before and never had any trouble with them. So storage pools. So what I've done on the Hitachi RAID 10 storage pool is I've taken these 4 drives and I've put them together into one big physical disk. And then I create a virtual disk on that then has 1 terabyte of combined storage. So even though there's 2 terabyte of storage, I've added some redundancy. So these are mirrored sets of drives. That's why I call it my RAID 10, because it's RAID 0 plus RAID 1 or RAID 1 plus RAID 0, however you want to call it. So there is some failover on this. And then, I've got details on it. So I've used it's called storage spaces now in Windows 11, but I've used it on server before. It's very reliable. It does give you some increased speed. These are spinning Rust disks, so it's spread the load out across all these platters, which should give us some better access time. And then the SSD pool is consisting of 3 different oddball SSD drives. And those are in I'll show you. Those are in a simple RAID 1 or RAID 0 pool. They're just all pooled together with no redundancy. And there's no hope of recovery of data if one of these drives should fail. But when SSDs start to fail, they typically fail at writing. And they typically fail right around the same time as the others do, if you buy them around the same time. And you should always have backups of your virtual machines anyway. So that being said, that's why I set up those drives the way that I do. And it's trivial to set it up in Windows. All right, folks, so I'm going to stop the video right here, even though I have a bunch more content available. Trust me, I can make lots of content. I want to save that for another episode, and it's basically going to be how I configured those 2 Windows 2025 servers, but that's more suited for the LabNet series. So once I get that up and running, I'll save that footage for then. So, but today the point I was trying to make was sometimes the right tool for the job is a Linux-based machine, or an ARM-based machine, or a Raspberry Pi, or a big high-end server. It just depends on your needs. And sometimes the right software is Windows Server, or Windows 11 or Windows 10. Sometimes the right software is Linux. It just all depends on your situation. The problem with that Dell R730 is I don't like having equipment around that I don't use, or that just sits there waiting to be used. It just annoys me. And the way I had it configured before to share those video cards out to virtual machines. I just wasn't ever using that. So, but I do have the need to run these larger language LLMs. And that's the main thing that that machine gives me. And then the other benefit is I can play with Windows Server on there and Hyper-V, put it together with another machine in the lab, and then those two we can do Hyper-V things on. So that's why I made the decision to go this way. Your mileage might vary. Now, I still have to load Ollama for Windows and get OpenWeb pointed to that Ollama and see how that all works. But as far as my understanding goes, Ollama is going to still support those video cards. As long as you got the drivers loaded, it should see them and be able to divide up the task between them. We'll see. So anyway, thanks again for coming to see this old guy. And we hope you found the video entertaining and informative. As always, please give us a like, give us a dislike, leave your comments. It's all interaction. It's all greatly appreciated. I appreciate your patronage. Just want you to know that. Subscribe if you're not already a subscriber, and click that notification bell to be notified of new videos when they come out. And you can find everything you ever wanted to know about Unky Joe's Playhouse if you go to unkyjoesplayhouse.com. That is our central repository for all of our social media links, donation links, everything. You can find it there. And I urge you to sign up. We don't share a mailing list with any advertisers or anybody else like that. I don't share your information. It just gives me the ability to notify you separately from YouTube that I've got new videos up for you to see. So go check that out. Again, unkyjoesplayhouse.com or .net. Either one of those will take you to it. So thanks again for coming to see us. Don't forget, we'll see all of you on the other side.
I've been watching old Unky Joe. From Texas heat to where the cacti grow. Fixing server solar power in the land. Hoping that his plans all stand. Making life a touch more bright underneath those southern lights.